which is factoring first.
Mm-hmm.
Okay, so let's take I can't even cover up the answers. So, which would be helpful. So if we factor that, we get x plus 3 times x minus 5.
Mm-hmm.
If we factor the bottom, we get x plus 3 times x minus 3. Now you can cancel out the x plus 3's, and you're left with whatever is left over.
Right.
Multiplying rational expressions is the same thing. You're going to factor wherever you can factor and cancel wherever you can cancel.
Right.
So tell me how to factor the top left. Hold on. The top left numerator factors how?
The top left one?
Just take them one at a time and do whatever factoring you can do.
So...
How do you factor that? Better?
So that 3x one?
Yeah. Taryn, it's better if you do not have your notes in front of you.
No, I was just getting a clean sheet of paper.
Oh, cool.
Right.
No, but that makes a difference. In other words, we want you to figure this out in your head rather than copying from the notes. That's why I've got it covered up. So what's the greatest common factor in that expression?
1.
By greatest common factor, I mean what's the largest thing that divides into each piece evenly? What's the largest thing that divides into 3x?
3.
About 3x.
1. Yeah.
What's the largest thing that divides into 3x squared?
3x squared.
3x. Well, no, you're right. It's 3x squared, but we want the largest thing that divides into both.
Right.
Which means it's 3x only.
Mm-hmm.
So factor that for me. If 3x is the factor, what am I left with?
You're left with x squared.
What goes,
or just x.
What goes here? What's 3x divided by 3x?
Just 3.
No.
Or 1, actually.
There you go. Now, when you've done the first step of this problem, check to make sure that when I remultiply it back together again, I'm going to get 3x. I do.
Mm-hmm.
What goes here?
Just x.
Right. 3x times x is 3x squared. So we've factored that part properly. How about the bottom?
The bottom would be...
This is more traditional factoring. In other words,
right.
There's no greatest common factor. We have to split it up into 2 linear factors.
Right. So it would be plus 4. No. Minus 4.
Before you figure out the final answer, do step 2. What do the signs have to be?
They're opposite.
All right. That's step 2. Mm-hmm. Now, what's step 3?
What adds to -5 and multiplies to be 4?
Factors of 5 that subtract because of that minus sign to the number 4. Well, what factors of 5 subtract to the number 4?
5 minus 1.
5 and 1. 5 and 1 are factors of 5, and they subtract to the number 4. Now, take the largest of those factors, 5, and put it with the sign of the middle term. That means the 5 goes there, the 1 goes there.
Okay.
Okay? Now, normally in order to cancel something from the numerator and the denominator, they have to be the same thing. But not in this case. The one exception to that is when you have the difference and it's switched around. What is that equal to?
Those just are just 1.
Negative 1.
Negative 1.
In other words, 1 minus x over 1 minus x is 1. But 1 minus x over x minus 1 is negative 1.
Okay.
Because this is always the negative of this, or vice versa. So this is one of the few exceptions where you can cancel and replace it with a negative 1. So I'm going to replace that, and I'm going to put negative 1 here. How am I going to do that? I'm just going to put a negative sign in front of the 3x. All right. So that's the first part.
Okay.
Now, in other words, I've factored the numerator, I factored the denominator, and I've canceled where I can. So let's go to the next rational expression. The top numerator, factor that for me.
So that would be just, so it'd be there's no GCF.
Right.
So then,
what's the second step? Once I've split up the x squared, what's the next thing I want to do?
Check the signs and their opposite.
Okay, good. Now what?
And then,
factors of 20 that do what?
That add to 1.
Based on this sign right here. If that's a plus, then they need to add to this coefficient.
Oh.
If that's a minus, then they need to subtract to that coefficient. So what are the two proper factors?
Why can't I think? 20 and 1.
Do those subtract to the number 1?
Oh, no. Let's see.
10 and 2 do not? Okay, let me give you a little trick here. When you're trying to factor something, start out with that.
Okay.
We know those are two factors. Now, cut this one in half and double this. So what?
So cut what one in half? Oh.
Cut the first one in half and double the other one. Those two also have to be factors of 20.
Right.
Do it again. Cut 10 in half and double
5 and 1.
Double 2.
Oh, 4.
You always have to do the opposite to the other one that you've done to the first one. And it doesn't always have to be in half. Sometimes it can be by a third, but then you have to multiply the other one by 3. So whatever you do to the first number, you have to do the inverse to the second number.
Okay.
Those are the two factors we're looking for, right? Remember, we were looking for factors that subtracted to the coefficient of the x term, which in this case is 1.
Right.
Now, which of those numbers goes with the plus sign? Which goes with the minus sign?
The plus sign would be 5, and the minus sign would be 4.
In other words, you take the biggest factor, put it with the sign of the middle term. So that is 5, that's 4. Okay, so, well, even before I go any further, I can see that I'm going to be able to cancel that x plus 5 with this x plus 5 down here. So let's just do it before we even look at the denominator. Now, it's important to know that when you cancel those, you replace them with a 1.
Right.
Now we got 3x down there. That can't be factored. So what can I do now?
You can, let's see.
Can I cancel anything more?
No.
Well, what about
Yes.
that 3x
Okay.
with that 3x?
Right.
Okay, what's it leave in the top?
Just a negative one.
Negative 1 times x minus 4. What's it leave in the bottom?
Wait, x minus 4. And then over 3x.
No, that got canceled.
Oh, over 1?
Yep. Now, one last simplification. What is minus 1 times x minus 4?
That'd be negative x plus 4.
Which is 4 minus x. Remember that.
Okay.
Remember that when you have a minus b, it's always the negative of b minus a. So when you have a negative times x minus 4, it becomes 4 minus x.
Okay.
Okay?
Alrighty.
So that's why this says factor, cancel, and when it says cancel, it means replace with a 1. It doesn't mean replace with a 0. Multiply, factor, cancel. Okay? That's what we did all the way around there. They're just showing you the various steps. Notice what they did with the 1 minus x. They replaced it with a minus x plus 1. Well, that cancels with this x minus 1. Only it doesn't cancel, it becomes a minus 1. I hate the way they did this. The way they showed this to you is extremely confusing.
Yeah. I like your way better.
They should have put this negative sign in front of the parentheses, and they should have put this as x minus 1. That's the way to think about it. In other words, you know always that a minus b, no matter what a and b are equal to the negative of b minus a. Well, you don't believe it? 4 minus 3 is equal to the negative of 3 minus 4. Well, that's negative 1. Negative times negative 1 is positive 1.
Right.
All right. And finally, they show you that it's minus x minus 4, which is the same thing as if you distribute that negative sign, you get minus x plus 4, which is the same thing as 4 minus x. God.
Okay.
They screwed up on so many levels here.
Yeah, that's why I have you.
All right, let's see. 504 was the same as 6505. In other words, this is the second document you sent me, but it's the same as the first. So,
Oops.
well, that's all right. I'll open up this one. Let's talk about the hyperbolic function. The most basic hyperbolic function is this, which graphs like this. X can never be 0, as the graph shows, and Y can never be 0. There's no way to make Y 0. You can make X whatever you want, and Y is never going to be 0. Okay? So the most basic hyperbolic function of all is this one. You have horizontal asymptotes at Y equals 0. You have vertical asymptotes at X equals 0.
Okay.
Everything they're showing you in this image is kind of a variation of that. In other words, it's some number over X minus some other number, and then plus some vertical shift factor. Okay, so let me take an example of what they're saying. If I said Y equals, let's take the most simple case. Well, that's my same graph, only everything has been moved up by 2. So now, instead of a horizontal asymptote at Y equals 0, I have the horizontal asymptote at Y equals 2. Still have a vertical asymptote at X equals 0 because X still cannot be equal to 0. And if I graph this, it looks like this. I use my asymptotes as my grid, and it's hyperbolic still. Whoop. So it looks like that. Not much difference. In other words, once I've drawn my vertical and horizontal asymptote, I know how to graph it. Okay. Now let's get one step more complicated. Let's put an X minus 3 plus 2. And that's what they're talking about. Some number over X minus another number plus K. Okay? So it's just a variation of the hyperbolic function. Where's my vertical asymptote?
It would be at -3.
At -3. It's whatever makes this 0. What makes that 0?
Right.
What X value makes this 0?
+3.
Okay, that's where your vertical asymptote goes.
Okay.
Where's the horizontal asymptote go?
At 2.
There's my new grid. I just draw my hyperbolic function on this grid.
Okay.
Okay, that's all you do.
That way makes way more sense now.
Now, if I put one more number here, let's make this a 5. Is all that 5 is a vertical stretch factor of my hyperbola. It doesn't affect the general shape. I mean, it affects the shape, but it doesn't affect the general layout. I still have a vertical asymptote, I still have a horizontal asymptote, and I'm still going to draw this function as hyperbolic. The only thing is that every point that was just a couple of things away from this horizontal asymptote is now 5 times further away. So the effect of that is to flatten out the hyperbola.
Okay.
It's still going to be asymptotic with those asymptotes. In other words, as X goes to infinity, Y will approach the horizontal asymptote. As X goes to negative infinity, y will approach the horizontal asymptote, and y will never, this graph will never cross the vertical asymptote, because it can't. There's no way you can ever let x be 3. If you let x be 3, you're dividing by 0, and that is a no-no.
Okay, so what if you had, if it was like a negative number in the numerator, would it just be on the opposite side of the graph?
Yeah. In other words, these hyperbolic functions don't have to be in quadrants 1 and 3. They can be in quadrants 2 and 4. Sometimes they can be in 1 and 2. And
Right.
you're absolutely right. What matters is if you have a negative sign. It's hard to tell, actually, which quadrants they're in until you test it. As long as everything's positive, then you know it's going to be in quadrants 1 and 3.
Okay.
Sometimes you don't know. In other words, sometimes you have something that looks like this. Oops, hold on. That thing right there,
Mm-hmm.
can you tell which quadrants that's in?
No.
Can't either. However, once I lay out my grid, I can test a point. What do I know about this? Where's the vertical asymptote?
At 0.
Nope. It's whatever makes the denominator 0.
Oh, so at -2.
Okay. Where's the horizontal asymptote?
At positive, or
Correct.
at 1.
Yeah, very good. Okay, so there's my horizontal asymptote. So there's my grid. So now the question is am I in first and third, or am I in second and fourth? Well,
Second and third.
it's not going to be second and third. It might be second and fourth.
Oh, yeah.
Let's find out by testing a value for x. If I plug in 0 for x, which is right here,
Mm-hmm.
and I end up here, then I know I'm in first and third. If I plug in 0 for x and I end up below, then I'm in second and fourth.
Okay.
What do you get when you plug in 0?
Don't you get,
Plug in 0 for x. What do you get? What is y?
y would be, sorry, I'm a little slow today. It'd be -1 over -2.
-1 over +2.
Over positive. That's what I meant, sorry.
Yeah, in other words, it's 0 minus 1 over 0 plus 2. Well, that's -1 over +2. Which means that if I go to my graph here and I substitute 0 for x, I can tell that my answer is right there.
Mm-hmm.
Well, that looks like second and fourth quadrants. In other words, I've just answered my question. Am I in first and third or second and fourth? I have to be in second and fourth.
Okay.
And I could have plugged in anything you want for x. I could have plugged in x equal 1. I could have plugged in x equal 3. The only thing I couldn't plug in for x would be x equal -2. But anything will answer the question as to which two quadrants I'm in. Any number I want. If I plug in 2 for x. Okay, if I plug in 2 for x, I get 1/4. Well, if I go down to my graph, 2 is way out here. 1/4 is right there. That puts me in second and fourth. In other words, that tells me I'm in the fourth quadrant, which means the other piece of this has to be in the second quadrant.
Okay.
Okay? So you can't always tell. Sometimes you have to test a point.
Alrighty.
Just looking at your notes here.
Yeah, no problem.
All right, let's take this example. We recognize that it's hyperbolic. Why? Because the x is in the denominator. The only consequence of this 1 is a horizontal shift. The only consequence of this 4 is a vertical shift. Well, and the consequence of this 3 is a vertical stretch. So I must be looking at a hyperbolic function. I have to be looking at a hyperbolic function, not only that, but I know it's in first and third because I see no negative signs.
Right. So as you said, third was or the 3 was a vertical
stretch. That's the only thing it is. In other words, I could write this thing the following way. I could write it as y equals 3 times 1 over x plus 1 plus 4. Well, if I write it like that, the plus 4 is clearly a vertical shift, and the 3 is clearly a vertical stretch.
I can barely see those notes. Off to the side.
My notes or your notes? Oh.
I had a thing. I had a thing in the way. That's all.
Oh, well, I was just going to say. So, can you see them now?
Yeah, I can see them.
Okay, good. I was wanting to know if you couldn't see them. It means there's something wrong with my system. Okay, so is all we're going to do is have a hyperbolic function. Where's the vertical asymptote?
The vertical asymptote would be at 4. No. Or it'd be at -4.
No. What makes what's the number one rule in math? If I had a 10 commandments of math, what would be number 1?
To cancel it out? To make it 0?
You're close. The number 1 commandment in math is thou shalt not divide by 0. And I'm not kidding you. You can go on Google right now and look up 10 commandments of math and you'll get 10 different answers. But every one will have number 1 as being you cannot divide by 0. So what value of x would cause us to divide by 0?
Nothing.
What value of x, in other words, what makes this 0?
-1.
Okay. That's the vertical asymptote. Wherever you find that you are dividing by 0, that is a vertical asymptote. That's how you get it. What's the horizontal asymptote?
It would be at -4.
Positive 4. This positive 4 means that the normal hyperbolic function that I would graph is being moved up by 4 units. There's my horizontal asymptote at 4. Once I've laid out my grid, now I know that I don't see any negative signs anywhere, so I have to be in the first and fourth quadrant. It's real easy once you lay out your 2 asymptotes to graph it. If you don't see any negative signs. If there was a -3 right there, then I would immediately assume that I'm in second and fourth, but I would pick a point and test it to make sure. So for our example, let's make it negative. How do I know which quadrants that's in?
You set x to 0.
It doesn't have to be 0. It can be any number you want. 0 is okay because it makes the arithmetic easy. When x is 0,
yeah.
what is y?
X is,
When x is 0, what is y?
it would be no.
Yep.
-3.
No. Plug in 0 for x. This becomes 1 times -3 becomes -3, but then we still have to add 4 to it.
Oh, right, I forgot the 4. That's why.
So when x is 0, what is y?
Y would be 1.
Okay. Well, here's x of 0, here's y of 1. So that point has to be on the graph of this thing. That tells me which quadrants I'm in. Notice that I can't be in quadrant 1 if I've got this point down here. In other words, that's one of the halves of the hyperbola. The other half is up there. So this one has to be in quadrants 2 and 4, not 1 and 3.
Okay.
And all hyperbolic functions are like this. It's really easy. You draw the vertical asymptote, you draw the horizontal asymptote, and then you test a point as to whether you're in 1 and 3 or 2 and 4.
Okay.
Now this range is maybe not obvious. When they ask you for the domain and range of this thing, well, it's clear that if we look at this function, x can be anything we want except -1. Right? X can be minus a billion. X can be plus a trillion. There's no limits on what x can be except for one thing. It cannot be -1. So that's why the domain is all reals except -1. Now, the range is a little trickier. The range is always trickier than domain. Range, you kind of have to either look at the graph or think about it in a little different way. Let's do both. If I look at the graph, what's the range? This is the graph, as this is here. What's the range? What are all the possible y values?
All the possible y values would be in the negatives.
Well, start from the bottom. What can y go to on the bottom?
Y on the graph?
This graph over here on the left.
You want me to count all those lines?
No. No. I want you to look at the graph. That arrow means it continues to infinity in that direction. This arrow means it continues to negative infinity in that direction.
Okay.
So it's negative infinity up to what? I could say negative infinity to positive infinity except for what number? What number is y never?
4. So it'd be to
4.
It'd be to 3.
All reals except y equals 4. That's why the range says this. All reals except y equals 4. Well, let's look at this algebraically. This part of it, 3 over x plus 1, no matter what x is, can that ever be 0?
No.
As x goes to infinity, what does the limit of this go to?
3.
No, 0.
0. Oh, that's it. Sorry.
As x goes to infinity, this quantity goes to 0. Anytime you have a number over infinity, you're going to 0. Well, 0 plus 4 means that even in the worst case scenario where x goes to infinity, y goes to at least 4. Well, since this can never be 0, y can never be 4. The only way y could ever be 4 is if 3 over x plus 1 were able to be 0. There's
Okay.
no value of x that makes this 0. Best
Okay.
you can do is get close to 0. Well, as x goes to infinity, this entity here gets close to 0, which means y gets close to 4. So whenever you're looking at the range on something that looks like this, looks like a hyperbolic function with a vertical shift, well, know that the hyperbolic point part can only go to 0 at its smallest. The absolute value can only go to 0. Obviously, if x is negative, this will go negative. But you can't get close to 0. That's why there's a horizontal asymptote at 4. Because in order for y to be 4, this part would have to be 0, and it can never be 0.
Okay.
Okay. And this basically says is that if you have a hyperbolic function and everything's plus, you're going to be in quadrants 1 and 3. This one says that if everything's minus, you're going to be in quadrants 2 and 4. But that didn't help us very much when we had x plus 1 over x minus 2. What is that? Well, we couldn't tell. The only way to tell was to substitute some value for x, figure out which quadrant you're in, and then you know whether you're in 1 or 3 or 2 or 4. So that little tip they give you on these notes isn't very helpful when you get something that looks like this. If you get something that looks like this, well, sure, that's going to be in 1 and 3. Minus 3 over x is going to be in 2 and 4. I can figure that out. But when I put the x in the numerator and the denominator, not so easy to figure out which two quadrants it's in.
Right.
The domain is always all reals except for the vertical asymptote. And the range is usually all reals except for the horizontal asymptote. All right. I see there's some exercises here. I don't have this book. Do you want to?
Yeah, we actually don't use those at the bottom of the page. This is for a couple years ago. He said he did these notes, and those are old, and he doesn't use those anymore.
Okay.
So.
All right. Let me just give you some that I'm going to make up.
Okay.
Tell me which two quadrants this is in. Can you tell by just looking at it? First of all, what's the vertical asymptote?
The vertical asymptote would be -2.
Nope.
Or it'd be +2.
Okay. What's the horizontal asymptote?
It would be -7.
No.
It would just be +7, sorry.
Can I tell whether I'm in the first and third quadrant of this grid or the second and fourth?
Um,
Can I tell without testing any points?
yes.
Yeah, in this case I can. In other words, this is a very simple case. I don't see any negative signs there other than the -2, but that doesn't count. By negative signs, I mean in front of the function, which means this is always going to be in first and third.
Okay.
Okay? Now, I'll give you another one. Vertical asymptote?
It would be at 1.
Nope.
Vertical.
Vertical asymptote always has to deal with division by 0. What value of x makes the denominator 0?
Positive 2.
That's the vertical asymptote. That's all you have to do. It's really easy. What's the horizontal asymptote?
0.
Good. Am I in first and third or second and fourth?
It would be third and fourth.
Never third and fourth. You're either in first and third or second and fourth, typically. I shouldn't say never. Sometimes it is in third and fourth. Sometimes it's in first and second. But only when you start squaring stuff.
So it'd be in second, or first and second?
No.
And
how can we tell? It's either first and third or second and fourth.
Second and fourth.
Well, don't guess. Tell me how I can tell.
Well, if you set x to 0, it'd be 1 over 2.
So if I set x to 0, what's y?
Be 1 over 2.
Okay, which is right there. So that point is on my graph. So that tells me which quadrants I'm in. Which quadrants am I in?
Second and fourth.
Exactly. In other words, the only way I can draw this hyperbolic function is if I'm in second and fourth. Okay? Now, having said that, if I change it to a quadratic in the bottom, everything changes. I still have a vertical asymptote at x equals 0. I still have a horizontal asymptote at y equals 0. But now I'm not in first and third. I'm actually in first and second. Like that. But that's only because I'm dealing with a second degree polynomial in that denominator. As long as everything is linear, that's linear. That's linear. That's linear. As long as I'm linear, then I'm going to be in first and third or second and fourth. And you merely need to test any point you want to determine which. Now, like I said, if there's no negative signs involving the x, I know immediately that that's in which quadrants?
Second and fourth?
No, first and third. There's no negative signs here.
Right. Sorry.
If I had this, that's going to be in second and fourth. I got a big negative sign sitting out there.
Okay.
If I have this, what's that in?
Wouldn't that be first and second?
First and third. It's never first and second when you have a linear.
Okay.
It's only first and second when this is x squared. Okay, so as long as linear means that the highest value of the x is 1. So as long as it's linear, it's either first and third or second and fourth. What is this?
That would be first and third.
Yeah, even though we have a negative sign, it's not in front of the x. Is all this negative sign means is our vertical asymptote is 3 units to the right. So if I'm plotting this, I got a vertical asymptote at x equal 3. I still have a horizontal asymptote there. There's no negative to this. It's first and third. If I change this denominator to 3 minus x, that changes everything. Now I have a negative sign in front of the x. And it's a little hard to just jump to the conclusion that that's going to be second and fourth. But you could. However, what if I do that? I make it minus 1 over 3 minus x. That's back to first and third because that's the same thing as positive 1 over x minus 3. That right there is the same as that right there. So you got to be careful of how many negative signs you're watching. Okay? In other words, I got a negative in front of the x, but I got a negative in front of the function, which kind of cancels it out. So this is first and third.
Okay. That makes sense. I was just going to ask you that question.
Yeah. And when you have something like this, you don't know until you test a point. Or if I have this, I don't know until I test a point. I can't tell by just looking at it whether I'm first and third or second and fourth. Sounds like a baseball game. All right.
I think that's all I have.
I can't think of anything else to even discuss with you.
Okay. Well, next week I should have some more to do.
Okay. The whole thing about hyperbolic functions is figure out your vertical asymptote, figure out your horizontal asymptote, and then work around those.
Right.
Okay. All right. Well, I will let you go, and I will talk to you next week.
All right. Sounds good.
All right, Taryn. Have a good one. Bye.
Bye-bye.